Hi all, this is Lakshmi, working as assistant professor in the Department of ECE at SNSCT. So today I'm here to discuss about the lecture series on emerging trends in sensors and MEMS. So the topic which I'm going to discuss now is all about the laser sensors. So generally, laser sensors, we call it as the precision optical devices because as it uses the laser light to detect, measure, and analyze physical parameters such as distance, position, displacement, and velocity. And also, they operate by emitting a focused laser beam. So that is targeted towards the target, and it analyzes the reflected light to determine the required measurement. So these are high precision devices and they are used in industries due to their high accuracy and speed, reliability. So these are mainly used to analyze the physical parameters like distance, position, displacement, and velocity. So, talking about the empathy of the laser sensors. So, we have to first consider the user experience. So, it means like we have to understand the real world needs and challenges of the users, environments, and applications where these sensors operate. So, designing and using the laser sensors with empathy. It involves the safety, accessibility, reliability, and adaptability in diverse conditions. So, for example, in industrial automation, the empathetic approach ensures that the laser sensors are robust enough to function accurately even in dusty or high temperature environments. So, that would minimize the downtime and stress for the operators who work on it. Whereas in biomedical applications, the empathy would be focused like the creation of these laser sensors, which provides non-invasive and pain-free and precise diagnostic support. And also, it should prioritize the patient comfort and safety. And it, with respect to the engineers, we have to design the user-friendly calibration system. So, for example, simple interfaces and energy-efficient designs, which address both the emotional and practical need of the users, has to be considered. So, the empathy mainly focus here on the safety, the technology, cost reduction in the operational cost, and in terms of biomedical application, ensuring the patient safety and the accurate diagnostic tool. So next is the definition of the laser sensors. So we can define the laser sensor as a high precision sensor which is used to which uses the laser light to detect and measure the physical parameters such as distance, position, displacement, and velocity. And there are a variety of applications, diverse applications, and the applications of laser sensors in industrial automation, robotics, medical field, etc., plays a vital role. So this is the definition of a laser sensor. So next is the ideate part, which is the working principle of laser sensor. We can categorize into three phases, that is laser emission, time of flight, and phase shift method. So the laser emission here, the laser sensors works on the principle of time of flight. We call that as triangulation, or another method is optical triangulation. So we can name the working principle of laser sensors as optical triangulation. So first step is laser emission. So it emits a focused beam of light, and when this beam touches the falls on the object, it reflects back to the sensor, allowing for accurate distance measurement. And so we also have this phase shift method. This also measures the phase difference between the emitted and the returned light, allowing for distance evaluation. So next is talking about the different types of laser. So we have, as we told, three parameters can be mentioned, like distance, displacement, velocity, etc. So we can categorize this into three types, like distance measurement sensors, position sensors, and laser scanners. So distance measurement, it would measure the distance with high accuracy. Position, it would identify the position of the object, and it is the very important part of the automation and control system. And laser scanners, so they would able to capture 3D images by scanning the surrounding environments and giving us the proper output. So these are the types of lasers. And applications, so as discussed already, wide range of applications of laser sensors like manufacturing, automotive industry, and agriculture, and also in health sector. So the lasers, they're used for quality control, that is checking the efficiency of the system, monitoring the production lines, and ensuring accurate assembly of the parts. So this is where how it is used in manufacturing. And in automotive, they are crucial in collision avoidance systems for precise measurement of distances. And in agriculture, they uses this for crop monitoring and optimize the usage of resources, etc. So advantages, it is having high accuracy, that is high precision, fast response time, and versatility, that is in various environments, even if it is dust or the other environmental conditions, this laser light would penetrate. So the challenges, like sometimes the rain, fog, and dust would affect the performance of the laser sensor. And cost consideration, this high quality laser sensors are of higher cost. And complex integration into this existing system would require some additional infrastructure. So these are the challenges, that is environmental factors, cost, and complex integration. So future trends is we are focusing towards the VLSI. So we go with miniaturization, reducing the size, that is smaller part, and integration with IoT, and improving the data processing steps. So today's assessment, which of the following principle is used in laser distance sensor? That is, as we have discussed, that is optical triangulation. So the time of flight, based on the time of flight. And what is the main advantage of laser sensors over ultrasonic sensors? It is of low cost, less sensitivity, higher accuracy, no need for alignment. So here the answer is, it is having higher accuracy and faster response time. Thank you.